Hi, welcome back to Mrs. Thompson's classroom. Today we're going to talk about piecewise functions. These are functions that are made up of multiple pieces, so we're going to have more than one function and each one defined on a given interval. So to begin with, we might have something that looks like this. So it's got two pieces. The first one has a restriction that is less than or equal to 0, and the second one has a restriction that is greater than 0. Okay, so we're going to have to graph each piece. So let's take the first piece. We know this is a line with a slope of -1. So the first thing we're going to do, though, is we're going to find this endpoint. So when x equals 0, we get -0, which is 0. So I'm going to plot a point at 0, 0. Okay. Now I plot a dot because it can equal it. Okay. All right. Then I do the slope of -1, and the less than means to the left. So it's going to be a line that looks like that. But I only take the part of the line that's to the left, so it ends up looking more like a ray, as was defined in geometry class. Okay, so then we're going to go to the next piece, and it is also a line, but it has a slope of 2. But I'm going to take its endpoint at x equals 0. So that'll be 2 times 0 plus 1, which is 1. So I will plot the point 0, 1. Now there's a difference here, though. This inequality cannot equal. So instead of putting a dot, I put a circle. Okay. Then I can draw the line with a slope of 2. So I'm going to go up 2 over 1, and I'm going to plot a point. Okay. And because it's greater than, I'm only going to go to the right. So I'll get a line that looks like this. Okay, and so those are our two pieces. Together, they make the function. Okay, and it is a function because it passes the vertical line test. Now we can talk about its domain. The domain would be all reals, because it is doing everything less than 0, everything greater than 0, equal to 0, so it's getting everything. Its range is going to be the y values that are greater than or equal to 0, because I have to go from this bottom point, and it goes up. Notice it does catch everything between 0 and 1, and then everything above 1 on both lines. So it's getting everything above 0 and including 0. Okay? Now sometimes we don't want the graph, we just need some information from our function. So we want to make sure we can just do our evaluating these functions, and it's going to be based on which piece does this x value fall into. So if I want p of 75, I need to remember that 75 is less than 100. Okay, so that means I'm going to use piece 1. That's this piece. And it tells me it's just equal to 35. Now the interpretation part is to remember that it tells me at the top that this is a cost. So this is in dollars. So it's going to be $35 for 75 minutes. Okay. P of 100. 100 is equal to 100. So that still falls into piece 1. Because piece 1 can be equal to. Okay. And so this is still $35 for 100 minutes. Okay, finally, P of 150. Well, 150 is greater than 100, so I'm in piece 2. So I'm going to do 35 plus 0.25 times 150 minus 100. So that's going to be 35 plus 0.25 times 50. So how much money is 50 quarters? Well, if you're not sure, we can take 25 cents times 50, and we get $12.50. So I have 35 plus $12.50, and I get $47 and, $47.50 for 150 minutes. Now, some phone plans do work this way, that you have a limited number of minutes or a limited amount of data, and so then they'll charge you for data after that. A lot of plans these days are becoming unlimited, so it's set up a little bit different, but this is very common in the past. Okay, so let's graph another one now that maybe we get a little bit better idea. In this one, again, I have 2 pieces. So the first piece, x plus 1 squared, is going for x less than 1. Well, this is a parabola, so it'll look like this, but it's going to start at 1. So I'm going to begin by finding the endpoint again. So when x equals 1, I'll get 1 plus 1 squared, which is 4. So I'll plot that point. Okay, now why did I just draw a hole? Well, I drew a hole because I cannot equal. So I draw a hole. I don't put a dot there because I'm not going to actually use that piece when x equals 1. Okay, then I need to draw the parabola going to the left. Okay, so you can even plot some more points if you need to graph your parabola. So maybe I pick x of 0 and x of -1, and this will give me 1 squared and 0 squared. And so we can plot those 2 points, and we get our parabola going to the left. Okay? Now, as a parabola, so be sure you find this vertex, just like you would if you were graphing the entire parabola. Okay, now let's do the second piece, -2x, when x is greater than or equal to 1. Well, this is a line with a slope of -2. But again, I'm going to start by finding the endpoint. So the endpoint is when x equals 1. So that would be -2 times 1, which is -2. So then I plot that point at 1, -2. Okay, now this time it can equal, so I put a dot, not a hole. Okay, and this is to the right. So I'm going to draw the line with slope to -2 going to the right, so it'll go down with a slope of 2. You can see it goes down and over. Okay? So we're just drawing each of these functions. We're just restricting the places where it can go. Now this one's domain will still be all reals. This one's range, however, is going to go from -infinity to that -2, and I will include the -2. But then I have a gap here, and the red parabola doesn't start until 0, and then it goes up forever and ever. And it does go up forever and ever because it goes up forever and ever on this side. Okay, but there is a gap here in the range. Okay, all right, one more. I'm going to do all 3 pieces. So I've got x cubed. So my end point is going to be when x equals 1. So that'll be 1 cubed So my point is at 1, 1. So I'll draw that point. And it is a whole because I cannot equal it. And it's greater than, so it's to the right. So it's not equal to the end, and then it's to the right. You do want to remember what a cubic function looks like. Cubics look sort of like this. This point at 1 is actually on this side, so we're just going to go up from there. You can plot another point, like I could put in x equals 2 to get another point in order to be able, and that'll be way up here off the graph, in order to kind of connect the dots. Okay, now I'm just going to do the next part, which is 2. And this is going to happen between -1 and 1. Well, it's just 2. That's a constant function. So it's going to be a horizontal line from -1 to 1. Well, the endpoints will be at -1, 2, and 1, 2. So I'll plot both of those first. It's a horizontal line, so I'll connect the dots. Okay. All right, the last piece is an absolute value, so it's going to make a V. Notice the point on the V here will be where x plus 3 equals 0, which is at x equals -3. Okay, so that's going to be right here. Okay, but again, I'm going to start by finding the endpoint. So that'll be when x is equal to -1. So I'll have -1 plus 3, and that'll equal 2. So I'll have a point at -1, 2. Okay? And then I'm going to this is for x less than -1, so I'm going to the left. And, okay, so let's draw the point first, and then we draw our absolute values. Notice where that dot is here. I found the bottom of the absolute value. So I have 3 pieces. Now for this function, my domain is still all reals. Okay. The range, let's look, the bottom point is right here. So the range is going to start at 0 and include that. And it goes up. And it keeps going up. So it's going to include everything because this is going to keep going on this end here. Okay. All right. So you can graph these in your graphing calculator. If you have a TI 83 or 84, you have to figure out how to put the restrictions in. But the calculators do have the inequalities under your test menu. And you can also graph them on Desmos.com, and some of the other online graphers will allow you to put the restrictions in. But it's good practice to figure out how to do each of these pieces on your own. And it's always a good practice to make sure you understand how that might affect the domain and the range. So hopefully that helps, and I'll see you next time. Bye-bye.